stuff, then you should see implicitly and think, oh man, that's great, because that is a lot less work. When I find F inverse implicitly, you just switch them and call it good. You're done. If they want explicitly, that means you have to solve for the inverse after you switch. Okay? Oh, there's right there. How about that? So, if I solve for F inverse, then how do you isolate F inverse, please, using rules of algebra? Subtract 3, divide by 2, and how do you get rid of the natural log? Natural log of x minus 3 over 2 is the inverse. Okay? All right. Now, when you talk polynomials, then things can get a little dicey here. So we're going to do just this numerically, not actually find the whole inverse function, but just values. If I asked you to write F inverse at, what does that mean? Oh, F inverse at 1. I'm not sure what I wanted here when I wrote these notes last year, but let's go here. If I put x equal 1 in, the inverse at 1, you have to figure out, where do I put that one? You don't actually have to put x in and y in and solve. You can actually do the old switch. On the inverse, x equals 1 is y equal 1 on the original function. Remember, the inverse is the idea of switching x and y. If that's 1 in the inverse, then that's the same as 1 for y in the original. Now, if you put 1 in the original for y, or f, then you're really saying what x gives you that result. The good news is you're not going to have to do this by synthetic division, all that cube solving. You can usually do this by guess and check in calculus, because they're focused more on the calculus of it, not the pre-calculus of it. So what is x that makes that true? Just guess and check. What x would make it true? 2. Yeah, that's it. Okay? So F inverse, given this function, F inverse at 1, which really means if the original function, if the inverse has an x of 1, then the original must have had a y of 1. Well, that has a corresponding value of 0. F inverse at 3 then. That's the same as if I put 3 in for y in the original and say what was the x. That you can also probably do by guessing. What is it? What x would make that true? 1. Okay? Try one on your own. F inverse at negative 9. Yes? Are they? What is your equation? Darn it. Shoot. Sorry, I wonder why I changed this. What about this one? Is this the same also? Okay. Actually, I guess I don't need to paste it in. So, I'm sorry, your function is 1 plus natural log of x? 8 plus natural log of x? And what was the question associated with it? F inverse at 9. Okay. All right. Give that a go. Sorry. And B is different? Okay. We'll come to that in a second. Let's do A first. Sorry.
That's C.
Oh, this is C. All right. Do C right now, and then we'll come to B. I apologize. All right, what'd you get? All right. This means in the original problem, 9 is the result, and what is the x that would make that? Now, log of x needs to equal what? 1. And so log of what would be 1? E. Okay, so this is E. B, what's B? The problem? F of x is x cubed plus 2x plus 3, and the question F inverse at 3. All right, that one you could probably do pretty easily. So the idea again is you say that if 3 is the x value on the inverse, then it must have been the y value in the original. So 3 would go in the y, or the function value. And you say what would the x have to be to make that? And that is 0, yeah? Okay. All right. Let's move on. You said this is the same as yours? All right. Let's talk graphically. If I wanted to look at the graphical relationship, what's the graph of that look like? Give me 2 attributes to it. Parabola is shifted to up or left or right? Left. Okay, that is true. Is the parabola shifted left too? All right. Now the inverse would be x equals y plus 2 squared. We've been talking about the inverse being the idea of switching the x and y. Yeah? In this case, we're dealing with y's, not inverses, or not f. All right. How do you graph that? It's a parabola, but in what sense? Opening how? It's opening to the right. And the vertex, remember, I recommend that when you go to think about how the shifts go, don't try and memorize rules. Think about the bottom happening because the least a square could be is 0. Yeah? That's what makes a vertex, is what makes the 0. What makes this 0 is -2. That's why it's shifted left to, not because your teacher said memorize this fact. It's because the least that can be is 0, and that happens when x is -2. That's why it's shifted left to. This, the least the square can be is 0, and that happens when y is -2. And so the graph looks like that. Now, if we talk about the relationship between a function and its inverse, there's symmetry to it. Across a line. Across what line? Well, it's a perfect reflection across y equals x. Now that makes total sense to me, because what do we do when we find an inverse? We switch x and y. Well, if we switch x and y, it's a perfect reflection across that mirror. So inverses are reflections across y equals x. Cool? All right. Let's go on to, these are out of order. Is this what you have? Find the inverse of f of x equals root of x plus 2? No. No? Gosh, I wish I would have made my changes here. Give me 1 minute while I call up my new notes that I apparently made wholesale changes to. I don't usually make that many changes. All right. E to the x plus 2 is what you have? Okay. Whoa. Just a second. I'm going to make all my copies here. All right. Sorry. Okay. All right. Find the inverse of including composition. All right, this is stuff where the derivative is going to come from, so this is important for later. Will you find the inverse of that function, please, really fast? Using function notation, not y. What do you get? Okay, perfect. Now, if you're asked to prove they are inverses are supposed to undo each other. Think of it like they're opposites. Think of it like two machines that undo each other's effects. So if you put something in, you added 2 and subtracted 2, then they would undo each other, and you're right back to where you started. If you're right back to where you started, then you're right back to the x you put in. So if you're asked to prove two functions are inverses, then it must be the case that if you use one function, then take that result and put it into the next function, they should undo each other, and you're right back to whatever the number is you started with. So if I were to prove these are inverses, I could put f inverse into f, and hopefully they would knock each other out. Now f is the idea of e to the blank plus 2. And the inverse is log of x minus 2. So if I put the inverse into the function, that's what I would look at, yeah? And the first thing that would happen is the e and the natural log would knock each other out. I have x minus 2 plus 2, which is right back to the x you put in. You try the other way. Prove that if you put f into the inverse, that they will undo each other. It should look something like that, yeah? All right. If I asked you to find the domain and range of f and the inverse, f equals e to the x plus 2, we could do that graphically. What does that 2 do to the graph of e? Shifts it up 2. So instead of the normal horizontal asymptote at the axis, now you're going to have a horizontal asymptote at y equal 2. Instead of a normal x-intercept, or y-intercept rather, of 0, 1, now it's going to be at 0, 3. And then the typical E shape. What's the domain then? Let's go interval notation. Left to right. Negative infinity to infinity. What's the range? To infinity and not inclusive because it never actually touches that asymptote, yeah? Now let's consider the other function, f inverse, which is natural log of x minus 2. We know natural log normally has a vertical asymptote at x equals 0, but now it's going to be shifted which way? Right 2. So now instead it's going to have a vertical asymptote at 2. No shock there. This had a horizontal asymptote at y equals 2. The inverse will have a vertical asymptote at x equals 2. This has a y-intercept at 0, 3. The inverse will have an x-intercept at 3, 0. And I think you'll agree that those have that symmetry across y equals x if I had put them together on the same graph. What's the domain of this function? I cannot take the log of 0 or negative, so the domain must be that x must be 2 to infinity. and the range negative infinity to infinity. Obviously, then you can see that the domain of the original becomes the range of the inverse. And that makes sense because x and y got switched. And the range of the original becomes the domain of the inverse. Okay? Moving on. Is this matching what you have? Okay? Above, when we graphed y equals x plus 2 squared, the inverse was not a function because the inverse fails the vertical line test. When we graphed the inverse there, the inverse is not a function. For any one x, there are actually multiple y's, yeah? Now, the reason the inverse failed the vertical line test is because the original failed the horizontal line test. If the original fails the horizontal line test, then it's not one-to-one. The function's one-to-one. That's not a typo, by the way. IFF is math and logic phrase for if and only if. And that's actually a really powerful logic statement. It's a reversible conditional. I'll let you study that if you become a lawyer, a pre-law student. All right, a function is one-to-one if and only if any y value can only be made by one x value. If a function is one-to-one, its inverse will be a function. A function is one-to-one if its derivative is monotonic. Now, that one actually makes sense here. Wouldn't you agree that a function like this is not one-to-one? Yeah? If you think in terms of calculus, it's not one-to-one because the function was decreasing and increasing at two different places. That's what makes it not one-to-one. It doesn't go back and repeat itself. But if the derivative is monotonic or only has one sign, whether it be increasing or decreasing, then the function will always have to be one-to-one. Would you tell me real quick which of these are one-to-one? Just give me a Y or an N for yes or no. Feel free to think visually if you like. The horizontal line test is probably the easiest way to go if you know the graph. Okay. So, what did you say for the first one? Yes or no? No. What about tangent? Yeah, I know one curve is, but is there just one curve? No. Okay. What about x cubed plus 1? That is a yes. What about x squared times x minus 1, which is a cube with zeros at 0 and 1 and a with bump? So that is a no. What about absolute value of x? No. That's a no, and e to the x? Yes. Okay. All right. In order to make the inverse a function, you often have to restrict the domain of the function so it can have an inverse function. Now this is big for calculus. You want the inverse to be a function so it is differentiable and you don't have to deal with implicit differentiation for a lot of reasons. So for example, sine of x, we know it goes forever to the origin, preferably like that. And so obviously it's not one-to-one. If we wanted it to be invertible, then we would have to restrict the sine curve so it was only one-to-one. Now, you could do that in a lot of ways. I guess I could go all the way over here, but it's logical to want the part of the graph that's close to the origin. Yeah? So we choose the point the part of the graph that gets all the y values I possibly can before it starts to fail the horizontal line test, and that is from there to there. If you then were to restrict it, okay, if you were to restrict it in such a way, then the inverse would be a function. And instead of the angles on the horizontal, the angles would be on the vertical, and the side ratios, or opposite to hypotenuse ratios, would be on the horizontal. And your curve would look like that. And that is a function. It fails, or passes the vertical line test. Tangent, same deal. If tangent looks like this, and it fails the vertical line test, or the horizontal line test, because of all those repeated curves, and that would make sense that if we wanted the inverse to be a function, we would take only this red piece of the curve, so that the inverse would be a function. The inverse, or inverse tangent, is something like a graph with horizontal asymptotes instead of vertical asymptotes. Still existing in the first quadrant. Okay? Absolute value. Normally it looks like this. How could you restrict it so it only has one to, or has one-to-one, or passes the horizontal line test? Positive only, yeah. If you only took this piece, then you would be good to go. The inverse then is, well, what would happen if you switch that? If you took only the positive, then isn't f just normal old x to the first, or a slope of 1, a y-intercept of 0? And so the inverse is itself. And last but not least, if you were to take the parabola shifted right to, let's say I want to make this one-to-one, so the function is an inverse, it would make sense to take piece. Which piece? I'll use that one. If I take that one, then when I go to invert it, it would be, oops, positive 2 like this. The part that I'm taking would be, instead of x's 2 and above, I'd take y's 2 and above, so I would only get that piece. What is the graph of that piece? Or the equation of that piece? Think of it like this. X equals f inverse minus 2 quantity squared. That means the square root of x plus or minus equals f inverse minus 2. So f inverse is 2 plus or minus x. Now that's not a function because of the plus or minus. It yields two values in most cases. So in order to make it a function, we choose plus or minus. In this case, we're going to choose the plus version. So the inverse is 2 plus root x. We'll do that still in differential equations. Okay, last but not least, this is pre-calc type skill. You need to remember that arc sine is only from negative pi over 2 to pi over 2 inclusive. Oh, wait, let's go unit circle, sorry. Yeah, I'd rather do this in a unit circle sense. Okay, remember, first of all, that in normal trig, you take the sine of an angle and you give a side ratio. In inverse trig, it's the opposite. You take the inverse sine of a side ratio and you give an angle. But we restrict it, so it's a function, and the angle can only be in the negative pi over 2 to pi over 2 region. We talked about that on the arcsine graph. It's only between negative pi over 2 to pi over 2. Move everything around. Okay? Arctangent. What is it between? Negative pi over 2 to pi over 2. Now that's not inclusive, and that's not inclusive because tangent doesn't ever actually equal anything at pi over 2. It's undefined there, so you would never give an answer of pi over 2. It is up to there, but not inclusive. What about arc? Cosine. Our cosine obviously is first quadrant, but it wouldn't do any good to use this quadrant because wouldn't that be the same positive cosine values? You need a place where you can get negative cosine values. Cosine is adjacent, so to get negative adjacents you have to go in the first and second, so it is 0 to pi. All right. Last but not least, inverses, or the reciprocals. Reciprocals, arc cosecant is the same as arc sine. Arc secant is the same as arc cosine. The only one that's different is arc cotangent. Arc cotangent is 0 to pi. Not inclusive, it should be soft. It's not the same. All right. You should be able to do these in about 2 seconds piece, so I'll give you a minute or two. And would you make sure you give me, there is exactly one answer. Not multiple. The only answer in the acceptable part. Okay? Okay? Our cosine of 1, our inverse cosine of 1, 0. Arc sine or inverse sine of root 3 over 2, pi over 3. Inverse tangent of 1, pi over 4. Inverse secant of root 2. That's pi. You should see root 2 and think pi over 4, and then say what quadrant, and if it's positive, it must be in the first quadrant. Inverse cotangent of root 3. This is where I think visually here. Tangent is opposite to adjacent, so this is adjacent to opposite. If the adjacent is root 3, then the opposite of 1, that's a 30-degree angle, so that is pi over 6. Inverse cosecant of 2, that's like inverse sine of a half. Inverse sine of a half is 5 or 6. How do we do? Those are the positives. Let's see how we do with the negatives. Inverse cosine of negative 1/2. Cosine is 1/2 at a pi over 3 kind of angle, but inverse cosine is negative in the second quadrant, so you should be giving me 2 pi over 3. Inverse sine of -1, that is at 3 pi over 2. Arctangent of -√3 over 3 is something like a pi over 6, but in the appropriate quadrant, it would have to be in the fourth quadrant, so that's negative pi over 6. Yep.
No.
This one? Yes, sorry, negative pi over 2, not 3 pi over 2. Sorry, yes, not in the acceptable range. Thank you. Inverse secant of 2 pi over 3, that's like cosine of -√3 over 2. That's what, a 30-degree angle in the appropriate quadrant, and so that's 5 pi over 6. Inverse cotangent of 0, I think adjacent to opposite, the adjacent is 0, so that is, when the x is 0, that's pi over 2. And that's like inverse sine of -√2 over 2. So that's a pi over 4. In the appropriate quadrant, that's negative pi over 4. How'd you do? Those should be soft. On the next test, there will be about 10 of those, and that'll be 10 points. If you're good at those, that'll be a gift. If you're bad, you'll just drop your grade 1 letter. Okay, last but not least, these are more typical in other trig textbooks. This is just commonplace in others, but ours doesn't do a ton of it here. The idea is that the inside governs or manufactures some kind of picture, and then you take the trig on that picture. Now, this is an adjacent to hypotenuse ratio of 2 to 3. That would mean that the triangle has an adjacent side of 2, a hypotenuse of 3. It looks like that. Then you take the sine of that angle. Now, the sine of that angle would be the opposite to hypotenuse ratio. So you would now need to find the opposite. The opposite by Pythagorean theorem is square root of 5. And so the final answer of sine is opposite to hypotenuse is root 5 over 3. Okay? So you first draw the picture, then find the opposite side, and then you find the sine. Try the second one on your own. What do you say? It's -3/4. Okay? If it's sine, it's opposite to hypotenuse. If it's negative, it's got to be in this lower quadrant. So the opposite of -3, hypotenuse of 5 is that way. I then found this next by Pythagorean theorem or 3, 4, 5 knowledge. The adjacent side has to be 4. Now you can do the tangent. Opposite to adjacent is -3/4. Try the other two on your own, and then we'll go over it. Did you get -√21 over 2? Okay. Okay, last one. Just work inside out. What's the sign of negative pi over 2? Negative 1. And what is the inverse cosine of negative 1? Or at what angle is cosine equal to negative 1? Okay, that one didn't click. Okay, that one is that. I think this is okie dokie. Questions on 90? Nope, that's C. Questions on 56 or 7? We're 2 behind. 56. Yes. All right, 56. Go. 1. Okay. Okay. Like as a replacement. 3.
20.
Okay. Okay. 1. So this is the one about the rectangular boxes. Since the boxes have square ends, so this I called x by x. You could have called it something else. I'm happy to call it whatever you want. This could be something else, so I called it y. But it has some restrictions. It said the sum of the 3 dimensions cannot exceed 16 feet. So you're given that x plus y, or the length plus width plus height, must be less than or equal to 16 feet. What is the greatest possible allotment of those dimensions to get the max volume? Well, let's start with max volume. If we're going to maximize volume, we need an equation for volume. What's the equation for volume in this case? X squared y. Okay? Then what did you do? We don't want to maximize volume yet with 3 variables. Okay, that's obviously where you got hung up then. I'll just say you should use a substitution fact. If you use the fact that y has to be 16 minus 2x, that'll get you a volume equation. Now you can find what you want for the volume.
Please drive to the Pledge of Allegiance. Please begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
All right.
Dublin, Japan travelers. We will have our first meeting this Friday during 7th hour. Please sign up with either Mr. Carson or Ms. Holland. Meet in Mr. Carson's room, W211. See you there.
Attention all junior high math lovers. Today is the AMC 8 math competition. Sign up for your math teacher for 7th hour, but then come directly to Mrs. Pruitt's room for 7th hour. Good luck this afternoon.
Attention all future color guard members. We will be having an interest meeting for Winter Guard on today during 7th hour. Winter Guard is open for all grade levels. No experience needed. Come check out the 3 state champion color guard. Bring clothes that you can dance in. See Miss Pushki for a pass.
Students,
Okay.
please come to the library of the prestigious
So
Colorado.
the key is online,
This book
and
award is
so
subject
if you want to check your
because
answers,
the
you can.
winner
But I
is
had,
45 kids.
there is no place for relative min.
No doubt.
Arizona State University from 10th Arizona will be
Oh,
counseling
actually,
today.
sorry, at 5 there's a
Sentinel's most
relative min,
notable
right?
alum are Kate Spade, Phil Mickelson, and Barry Bonds.
Oh,
If you would
man.
like to know more about ASU, sign up at
Relative min
counseling
at
for a pass. All students are
x
invited.
equal 5,
Make sure
because
the final care package is
Epcon goes negative to positive there.
ordered until Friday, November 3rd. Purchase on the Jeffco Fees website or at the
That's
financial
a
office.
mistake on my
Cost
copy.
is $15 for the
I
fall
was thinking
semester
max.
or $22 for the
Decreasing in
Don't miss
concave
out on
down.
the fun tradition
I would
or
start by
books.
gathering where you need to look.
High school students interested in working on the stage script for this
Decreasing
year's
is
musical.
F prime
There will be a
negative.
meeting this Thursday after school.
Concave
We will
down
be
would
meeting in
be
the drummer room.
F double
All students
negative,
are welcome, no
which
experience
means F
required.
prime
Come
sloping.
and be a part of the production.
So find where the
High
graph
schoolers, please join us in the cafeteria during 7th hour today
is
for some cake.
negative
Celebrate
and
National Science Day for the following
decreasing.
Isabella Scuturo, Shiloh Miller, Taylor
Hey.
Gustafson, and Larissa Hamlin.
That's today.
All fall athletes that have had a big locker are not in a winter sport need to clean your
So,
locker and
I
return
said
your
that
locker
that was on
to
zero to
Rio
two.
Italia today and tomorrow. Please take care of this ASAP.
See,
Dazzling Jack, all state gymnastics teams
Inflection
for the 2018 season were selected, and congratulations to the Dazzling athletes online. Tuesday in the class 4A first team.
Senior high school, there's an athletic leadership council tomorrow meeting. Meeting tomorrow at 6:40 in E100.
Also, don't forget to keep reading. Rich's sports class is currently in the lead. That's all you have to do. Have a great day.
so if the F double would change signs where F prime changes from increasing to decreasing or vice versa, so with those two places. And D. D is fundamental theorem. To find F at 0, you relate 0 to 5 through the fundamental theorem. Isolate F at 0. F at 0 is F at 5 take away the area, and that's given to you. So 7 minus, and that area is negative 11. So it is 18. Then do the same for F at 6. Hey, make sure I get 56 by the end of the day, please. The key is online. I know I said that yesterday, but today really is online. So, or come in for help.